Sorry about that. Okay, so continuing with his profile, for his undergraduate, Dr. Akintemi attended Adeyemi College of Education, now Adeyemi Federal University of Education in Ondo State, Nigeria. This was where he studied chemistry education. He did his NYSC at the College of Education, Minna, Niger State, where he lectured chemistry courses to NCE students across different levels. Thereafter, he proceeded to the University of Ibadan for his master's degree in physical chemistry. He bagged his doctorate degree from the University of KwaZulu-Natal in South Africa in the year 2022. Over the years, he has taught chemistry he has taught chemistry at various levels and prepared students for WAEC, NECO JAM, Cambridge, IGSC, and Cambridge A levels. Among his former students, there are veterinary doctors, dentists, mechanical engineers, current medical students, postgraduate students in the UK, and many more. He also offers tutorial services for chemistry and mathematics at Unique Insights. At Unique Insights, the unique tutors offer both online and contact chemistry and mathematics tutorials. So special consideration are given to high school students and undergraduate students. So if that's something you'd like, you can contact him. They make use of virtual platforms like MS Teams, Zoom, or Google Meet. So your location is not a barrier anywhere you are in the world. So presently, Dr. Akintemi is a postdoctoral fellow at the University of South Africa. He's actively involved in the teaching of chemistry and chemistry research. So with so much joy today, so much pleasure and appreciation, I welcome Dr. Akintemi to this meeting. Thank you very much, sir, for honoring our invitation.
Thank you, everyone. The host, thank you for having me on board.
It's so good to have you here, sir. Thank you very much. Okay, so going on, I'm going to be asking him questions on things with relating to chemistry and learning chemistry. The title of this Zoom meeting is Ways That We Can Learn Chemistry Effectively. So I discovered that there are certain ways to learn certain subjects. So the way we would study for chemistry is not the same way we would study for biology. It's not the same way we would even study for mathematics, right? It's actually different. And that's why we're running this subject series, looking at different subjects and ways we can study these subjects specifically, effectively. So today we are focusing on chemistry. And so if you have questions, please, you can some questions. I should be able to see them on the chat. So if you have questions, you can just send them to the chat or send them to me personally so that I can take them. But in the meantime, I'll be asking him some questions that I'm sure would also be beneficial to us. So please, let's ask questions, send them to chat, or you could raise your hands if you'd want to ask those questions. So I'll start by asking, sir. I have introduced you, but I would like you to briefly share your story with us of how you ventured into chemistry and got to the stage that you are presently at right now.
Okay. Thank you, everyone, for joining today's meeting. I'm delighted to have you all on board. And thank you, host, for deeming it fit to invite me. I'm sure there are quite a number of academics, and in fact, doctors of chemistry, but inviting me to this meeting, I see it as a rare privilege. So, how my journey into chemistry started was during my high school. My best subject in high school was mathematics. However, I think around my SS2, we had a new chemistry teacher, and this man was very passionate with his style of teaching. So that encouraged me to have more interest in chemistry. So chemistry became my second best subject, so to say. So at WIEC level, of course, it went well, not totally well, yeah, because there will always be challenges. So I had to rewrite. I didn't fail chemistry anyway. I didn't fail chemistry and math, but I had to rewrite my WIEC because of English and biology. So for admission, of course, in Nigeria, many of us wanted to study medicine. So, but unfortunately, I didn't meet up with the cutoff for medicine. Then at the University of Ibadan. So I was advised to probably opt for Adeyemi College of Education, which happened to be a college of education in my hometown, even though I was schooling then in Ekiti State, but I'm from Ondo State, Ondo Town in Ondo State. So I opted for that, and when I was to choose which course, I got more interested in chemistry, even than my best subject, which was mathematics. So that was why I chose chemistry. And sincerely, when I went for the post UTME, it was like classwork for me. By God's grace, I was confident. I knew I solved all the questions. I solved all the questions in post UTME. I passed, and then the journey began. Yeah, and then after that, all along, because of my interest in mathematics, remember I said mathematics was my best subject. So I always like those uh, courses that we offered in the higher institution that had to do with chemistry. So that had to do with mathematics rather. And on the long run, I got to understand there are branches of chemistry, and that aspect that is mathematical is called, or that is more mathematical now, is called physical chemistry. Yeah.
Yeah.
So yeah. So based on my interest as a trained teacher, because it's a college of education, though a degree awarding institution. So I went for degree, not NC. So being a degree awarding institution and as a trained teacher, of course, you will do your when we do teaching practice. That also gave me like more interest and enlightenment about the teaching profession. Yeah, so I chose that physical chemistry when I was applying for my master's degree program in University of Ibadan. Initially, I chose analytical chemistry because the analytical chemistry we did at undergrad also had some level of mathematics. But it
Yeah.
was before admission that a senior colleague of mine, also now Dr. Oyene Oba, a lecturer at Akumba Akoko, explained to me that, oh, it is physical chemistry that is more of the mathematics. That's the aspect that I like. So I had to do a change of course, and then I filed in for physical chemistry. Then I went for the we also had the entrance exam there at University of Ibadan. So we wrote the chemistry entrance exam, and by the grace of God, I passed. I was shortlisted. Then I resumed after my NYSC for masters into physical chemistry. After that, after completing that, then having worked for some years in Nigeria, I knew that I'm a scholar, but I understand the situations around us back home restrict many talent from blossoming. Let me put it that way. So within me, I knew I was a scholar, and then I just made that determination that I know I'm going to travel abroad to study abroad. That I'm not going to be limited by what is happening in Nigeria. Yeah, that was that strong decision in me. And with that, by God's grace, and then with also the support of some friends around, so I was able to get different links. Eventually, in 2018 to 2019, I got two offers, one to South Africa and one to Algeria. So I have to, put some things, weigh my options, and then I opted for South Africa. So that was how I came here and started my PhD in chemistry. And it's been a good journey. Yeah. Thank you so much.
Oh, thank you very much, sir. That was very detailed about your journey into chemistry. Thank you, sir, for sharing that with us. So I think now we have a better understanding of how you ventured into chemistry and why you are um, a very good teacher in it, because I can testify to that. I've been I'm still a student, so I've been a student, and I didn't know that you actually studied chemistry education. So thank you very much, sir, for sharing that with us. So I'll go into some of the other questions. Please, like I said, we can ask questions so that I'm already on the chat. So if you send any question there now, I would see your questions. So I can take them. Some of them might be some of the questions that I've already prepared. So I'll know how to, organize that. So please, you can start sending in your questions so that this can be beneficial to you. So the first question I would like to ask from the standpoint of students is, I've heard so much about how, I know generally a lot of students don't like maths because they think it's difficult or it's challenging. But for some reason, people don't also like chemistry. They'd rather do anything than to do chemistry. You know, the way I ventured into chemistry, quite similar to your story. I didn't initially want to do chemistry, but one way or the other, I found out that, okay, I actually, when I had to look for alternatives, I found out that I'd actually love to study chemistry as an alternative, since I couldn't do the initial course. When I tell people that, okay, I'm studying chemistry, it's like it's one big thing. Or even when I tell people, okay, I study chemistry, it's just like I did something very big. And I'm wondering, I didn't really see it that way, even from secondary school. So why do you think people view chemistry as a difficult subject, or people run away from chemistry? Even secondary school students, yeah.
Okay. Why the question now in summary is why do people run away from chemistry, right?
Yes,
Or see it as a difficult subject?
yes.
Okay. I would like to say that it's in two perspectives. One, it depends on the kind of friend that student has at that time, the kind of friend. Because sometimes your friend may not like chemistry. That doesn't mean you two shouldn't like chemistry. Peer pressure can cause that. Number two is background. Background in the sense that some students were not brought up to sit and read. So anything that stresses them, they try to avoid it by all means. So, and the truth is, every subject has its own peculiarity. That's number two. And number three, which is also very significant, is the type of teacher. Remember, while I was giving my own storyline, I mentioned that we had a new teacher in SS2. Yeah, the kind of teacher one has a lot of uh, factor in that. So I would like to lay emphasis on the type of teacher. So if the teacher is not the friendly type, number one, and if the teacher is not a good teacher, A good in the sense that the teacher may be brilliant, but may not be good at teaching. Yes. And then furthermore on that, if the teacher doesn't know chemistry very well, but just find him or herself in teaching chemistry, yeah, that's the truth. I actually passed through two different teachers I won't forget. I didn't regret passing through them, and I'm not blaming them for that. But sometimes people just get jobs based on connection, or at least they just need something to make ends meet. I
Yeah.
remember one of my physics teachers, a female. That woman didn't understand physics. She just found himself teaching physics. Then one of my chemistry teacher in SS1 too, that man, we copy example, everything to class, just put it on the board, be teaching gas laws, and we'll be writing the example on the board. And after that, we just give you assignment. Like, so the peer pressure, the background, and then the teachers. Yes. So, but what is the way out? The way out is that as students of chemistry, if your passion or if your ambition is for a science career, you know that chemistry is unavoidable. So what you need to do is just decide within you that don't decide within you that you will know it. That's the first thing. Have that decision that you know it. Even when your friends are saying negative things, don't care about that. Just have that focus that you will know it. And then how do you know it? One, sit down, read those topics that you can comprehend yourself. Then two, run to people who can teach you. Don't be shy to learn. I want to tell you that there's one of the participants here who is my junior colleague from UI, and he's also a PhD student at the moment. And despite the fact that I'm already a doctor of chemistry, he still teaches me some things because he knows it. We can't shy away from that. And then he also comes to me for some things. He learns them from me. So be willing to learn even from your classmates. Yeah. Thank you so much.
Thank you very much, sir. So the next question I'd like to ask is, so you already started going into ways that we can learn chemistry or ways that we can avoid or overcome the challenges that we face. You mentioned pressure, you mentioned background, that's peer pressure, background, and then the teacher who is teaching that subject. So we can't depend on these issues, rather we need to find a way to overcome these challenges. So we've already started getting into ways to study chemistry or overcome these challenges. So I'd like to ask, what are some how do you, as a student, how do you study for chemistry? And let me just make it broad like that. How do you study for chemistry as a student?
How I studied for chemistry. Um, I always refer to my early days because there's an adage in Yoruba. Wọ́n sọ pé ẹni tí ò bá ní tàn tó bá fẹ́ tàn, irú ẹni yẹn kò kí ń pẹ́ tán. Now this, whoever doesn't have a history and want to make impact, such a person will very soon fade out. Yeah. So how did I read for chemistry? Okay. I want to mention that all my education from primary school till date, they were through I passed through public institutions. So public primary school, public secondary school. So for the public secondary school, where we actually started chemistry from SS1, the first thing is I must have my chemistry textbook, a personal one. You can't be a science student and be borrowing physics, chemistry, biology textbooks, physics, chemistry, math, biology textbooks. No, you must have your personal textbooks for them all. So that the first response is I must have my textbook. Yeah. Number two, I must ensure that I don't miss classes. Yeah. Number three, when I'm reading now, straight to the question, when I'm reading that chemistry topic, try to relate it with life situations. Okay. Shortly before this meeting this evening, I was teaching a student. Then I was explaining about matter having space and occupying, having mass and taking up space. So when as a student I read, matter is anything that has mass and takes up space. Then I use a life experience, life situation rather. Okay, when I blow air into an empty balloon, the balloon was initially flat. When I blow air into it, it expands, right? It, when it expands, when that balloon expands, if initially, when the balloon was flat, if I put it on a scale, because the weight is very light, it's very yeah, light. So if the mass reads, let's say, 10 grams, then by the time I blow air into the balloon, tie it, and I place it back on the weighing scale, the weight, the mass must have increased to maybe 13 or 15. The difference may not be much, but there will be difference. There will be an increase. So what led to that increase? What led to the increase in air that I blew into it? It means that air has a mass and it occupies a space in the balloon. So that's how I read. So as I'm reading, I'll pick life experiences, put it around it. One more example before I end that question. If I'm reading, let's say, rate of reaction. Now I'm explaining as a teacher, but I'm also making you understand how you can also picture it. Okay, if I'm reading about rate of reaction is the amount of substance divided by time. That's simply rate. Either the amount of reactant consumed per time, or the amount of product formed per time. So that amount, let's say carbon reacts with oxygen to give me CO2. So if the rate at which CO2 is formed, if the mass is 5 grams, I'll divide that mass by the molar mass of CO2, which is 44. I'll get a value for the mass. Then the time, if the time taken is, let's say, 10 seconds, and then I'll divide it, I'll get a value. If another gas, SO2, is produced, sulfur plus O2 giving me SO2, is produced at the same time now, or at a different time. By the time I do my calculation and I get two different answers for the rate, so the one with a higher rate is the one with a shorter time. Remember, the rate is inversely proportional to time. So with that, I'll picture it and say, okay, rate is the amount of reactant consumed per time, or the amount of product formed per time. So you just always try and link it with a life experience, and then picture the definition again, try to memorize it. You don't just cram. As you are memorizing it, be linking it with life experience or day-to-day activities, and then it will stick better to the brain.
Okay. Thank you, sir, for that um, explanation. So I think now people think, or many students think, that history is abstract, and many of the things that we are taught, we can't see it or can't make sense of it. So how do we picture, there are many things that it might not is be easy to picture some of these things. So how do we um, picture these things and try to relate it to life experiences, especially the parts that seem really abstract?
Okay. So far to my knowledge, I don't think there's any aspect of O-level chemistry that we can link to real life. Um, For some of the high school students in this session, I think Toluwa Lashe was the first, and then she introduced herself, right? Toluwa Lashe, are you still with us?
Yes, sir. I'm still with you, sir. I'm still with you, sir.
Can you mention any topic? Just can you mention any topic
Um,
that comes to your mind that maybe looks abstract or just any topic? Then I'll link it to a live
Organic chemistry.
organic chemistry. Thank you. Organic chemistry is even the most practical, or is one of the most practical topics. So if you're talking about organic chemistry, what do you want to talk about? I want to talk about petroleum refining, fractions of petroleum. We have crude oil in Nigeria, and then what are the byproducts? We have petrol, diesel, all these things, gasoline. You can relate it. Then, if you are talking about organic chemistry too, where they deal with reactions, maybe there you talk about esterification, you talk about saponification, right? And many others. For esterification, what do you have? You have your carboxylic acid plus your what's the other substance? Your acid plus your alcohol will give you your ester. Yeah. For instance, your ethanol plus ethanoic acid will give you ethyl ethanoate. So you can link it with real life experience. Ethanoic acid, sometimes we have it in the lab. So just picture yourself taking that container of ethanoic acid in the lab. Then you have ethanol also. Though people drink alcohol around on the street, link it with that, right? And then you know that when you mix the two, now it's not what is done commonly around, but you can pick the reactant from what you have around. So you add the two, it's going to give you what? An ester. How do you get the correct formula of the ester? It's very simple. That topic, students see it as difficult, but I see it as very simple. Okay, to form my ester, I'm having my acid first. From the acid, I'll remove OH. Okay, from the alcohol, I'm removing H. And then I'm adding the remaining part of the alcohol to that acid to give me my ester. For instance, if I have CH3COOH as my acid, I'm adding it to C2H5OH, right? So from the alcohol, I'm removing H. From the acid, I'm removing OH. On my ester side, I'll be having CH3, COO, and then I'll have C2H5. So altogether, the byproduct will be H2O, which is water. Can you see that? So just picture it like that. As you're picturing it, write it down. Yes. So sometimes when you read, as you picture it, write it down. Then suggest another example for yourself. Write it down again. By the time you do that for like 2 or 3 times, it will stick to the memory. Thank you.
Okay. So what about the inorganic part of chemistry? I think that's personally, I would say the inorganic part is more, I found it more challenging. I don't know why people find organic chemistry to me was very simple. I don't know why people find that difficult. But the inorganic part where you have to, okay, sorry about that, where you have to get you have to the parts where you learn about electrolytes and things like that, things that you can't really see. How do we really understand these things?
Okay. Like the inorganic aspect, I think it starts the inorganic aspect. Sorry, 1 minute. 1 minute, please. Okay. For the inorganic aspect, okay, let me use the example you mentioned, which is about the electrolysis. Electrolysis is easy to understand. How do you understand it? For instance, electrolysis is the chemical decomposition of a substance through the passage of electricity, blah, blah, blah. Now, how do you picture that? Imagine yourself having a glass cup or a cup now containing, let's say, a liquid, and then you connect wire to it. The wire branches to left to right, and then it connects up with maybe a battery at the top, right? That's the passage of electricity. So where your battery is your current source. So the current goes through, it goes, maybe I think it enters through the anode. I've forgotten that aspect now. I may be wrong whether through the anode or through the cathode. So I think it goes in through the anode and then goes through into the solution. So once the electricity enters the solution changes. How does it change? It changes by discharging a metal present in that solution. Let's say CuSO4. Your CuSO4 now will be discharged on the rod that was connected to that cup. So it's discharged. So it's probably displaced, depending on what you have on your electrochemical series. It will probably displace maybe your potassium or your any other metal. And then the current continues to flow like that. So the passage of that current from your battery source as it goes down is what led to the chemical decomposition of your solution. So you can picture it. You can measure any other aspect. I'll link it. So it's just like that. Just try to link it. Just find something. Just imagine it.
Okay, sir.
Thank you.
Yeah. Can you hear me?
Yeah, sure.
Okay, sir. Thank you very much for explaining it and making it practical. So I'm seeing that people are joining and leaving the call. But for the people on the call, please, if you have questions, now is a good time to ask. You can just send it to the chat or send it personally to me so that I can ask the questions. I mean, don't leave here without asking a question, maybe something that you are struggling with. It could even be a particular area that you are presently struggling with in chemistry. So you could just ask that and our guest speaker would answer it. So I think, so we have some people studying for A-level chemistry, even WAEC, JAM, and all of that. So if there are specific ways, because given the fact that these things are something like A-level now is quite bulky, and you have to read it in a short amount of time in preparation for the exam, or even something like WAEC. So how do you advise that students study for these examinations, specifically A-level, WAEC, and JAM?
Okay. I'm going to respond using each of the exams. Yeah, explaining for each of the exams because God's willing, I've taught students at all the three levels. Prepare students for WAEC, for JAM, and as well for A level. So let me start with WAEC. For WAEC, it's like all you have learned in 3 years. You have to present it in 2.5 hours or 3 hours. So, for instance, for WAEC, just try and pick topics that you are comfortable with first. Try and revise those topics. When you revise those topics, the ones you are not so comfortable with, and also give them a special attention. See how you can understand them, and then by solving questions. Chemistry generally is not a subject you read and say, "Oh, I've read it. I'm going for exam." No. After reading, you need to ask yourself questions and then try to reproduce what you have read. When you are able to do that, it sticks better to the brain. It doesn't mean you will get it absolutely the first time. Even when you are trying to, let's say, uses of electrolysis. Electrolysis is used for electroplating, production of gases like hydrogen gas. Um, I think it's also used in the production of metals. Yeah, production of metals and so on. So when you are trying to remember those maybe 3 or 5 points in your notes, when you ask yourself the question, as you are saying it in your brain, then try to pick up paper and pen, write it down. Are you able to produce it? If not, if you're able to remember to, good, go back to the note. When you go back to the note, you read it again, then you can do other things. After some time, ask yourself the question, read it again. Then for also for WAEC, sometimes they ask for equations. For instance, production of sulfuric acid. That one I can't forget because of the way I put it in my brain. You may be asked to narrate, to describe it. You have to describe it with the aid of diagram. You will need to draw probably some diagrams there. Most times they may not describe. If you are just to describe without diagram, for instance, that production of sulfuric acid, industrial production now, it starts from your sulfur powder plus oxygen, giving you SO2. After that, your SO2 will react with your oxygen again, excess oxygen, to give you SO3. Your SO3 will react with H2O to give you oleum, H2S2O7. Then your oleum, I think your oleum will now, I forgot if it will react or it will disintegrate. It will give you 2 molecules of your H2SO4. So by the time you picture that, you picture the arrangement of the equation. The arrangement of the equation itself will give you an idea of how to write the discussion. Remember, you have read the discussion from your Ababio textbook. Having read it from Ababio textbook and then try to arrange the equations serially, then you'll be able to discuss and say, okay, if when you get to the exam, just list the equation first. When you list the equation, it will help you to give the storyline of the description easily. Exactly. So that's how it works for WAEC. And then for WAEC as well, you should know that your practical is very important. Don't joke with practical. Practical has a very strong weight in the grading system. So, for instance, if you're writing GC, it means you must know all those ions, the test for ions, you must know them offhand. If it is copper, they give you light blue precipitate, and then Cu2 plus the reagent that will be used, your HNO3 or anything, you should know the reagent, the color, and the confirmatory test. When it comes to titration, you should know the appropriate indicator for a particular acid combination, maybe strong acid and strong acid, you use methyl orange. When you have maybe weak acid and strong base, you use phenolphthalein. So all those things, you put them in, you try to picture them, memorize them, write them down, reproduce. So that gives you strength on practicals. Then your practical and then the theory. The objective most times, if you are well grounded in the theory and the practical, the objectives are not always difficult to get. So I think this is I've been able to do justice to WAEC. If anyone still has questions later, you can ask. Let me move to JAM. For JAM, I advise students to use the JAM syllabus. There's always a JAM syllabus. During our time, we used to have the booklet, the JAM syllabus booklet. But I think these days they are given CD. I think it's CD. I'm not too sure. I think it's CD you have to play. I'm not so sure, or if the booklet is still obtainable. So in short, for JAM, try to use the syllabus to read. How does that work? When you pick a topic in the syllabus, let's say matter or under sulfur and its compound, the syllabus will say candidates should be able to So when the syllabus is, candidates should be able to this, that thing they mentioned that you should be able to, that is what you will read. Because JAMB is more specific. You can't be reading the whole of your Ababio for JAMB. You don't have that enormous time, that luxury of time. But when you use your syllabus to read, the syllabus can say you should be able to define gas laws. They will mention certain laws and state the equation. So you know your gas law, maybe your Charles law, volume is directly proportional to temperature, provided pressure is constant, V directly proportional to P is constant. And then you know that, okay, you are going to have your V over P. That's your V1 over C1 equals to V2 over C2. Then you solve questions on it. For JAMB, when it's calculation, you solve questions. When it's not calculation, just read exactly what the syllabus wants you to know. That will help you to move very fast when you are reading for JAMB. Then for A-level is more technical and is more of application. It is less of memorization. It is more of application. Let me give an instance. If, for instance, we know that generally that when you put blue litmus paper into acid, it will turn what? What will it turn to? Blue litmus paper into acid, what will it turn to? The host can answer us. I know the participants are the most they are for.
It turns red or pinkish. Yes, litmus paper. Reddish or
Yeah,
pinkish.
blue litmus paper. Yeah, that's correct. Blue litmus paper in acid, it turns red. Or generally, we say acid turns blue litmus paper red, right? That's just a simple and basic statement. That's what you need for WAEC and JAMB. But when it comes to A-level is application. The A-level will ask you that same statement in a story way, telling you that a student, maybe a student put a paper or put a paper. They may not even call it litmus. Put a paper which was initially blue in color, and the paper turns red. Which of the following solutions could have caused that? Don't mind my English, but that's how it will be constructed. So in the options, you will see maybe HNO3, NaOH, KOH, Na2CO3. So what's the answer? The answer is what? HNO3, because HNO3 is the only acid in that option. Can you see the difference now? So that's how A-level works. A-level is more of application. They only ask very short definitions in A-level. Very, very short definitions, 1 mark, most times, 1 mark, 2 marks, 1 mark, 2 marks. Many others are applications. That's how A-level works. So for A-level, it's good to have a strong background in WAEC before one goes for A-level. Parents who maybe allow their students to jump classes, maybe from SS2, the student will not even write WAEC. Say, oh, I'm traveling abroad. They just start going for A-levels. Many a times the students get frustrated from the A-level class. Some even drop out. I've taught A-level students, some drop out. Maybe after the first, we have AS and A2. Some after AS, they drop out. So one needs a strong background in O-level to be able to fit in better into O-level. Thank you.
Thank you very much, sir, for that detailed explanations. I'll recap on some of the things you said. You mentioned, first of all, some tips for WAEC, and you said, first of all, every student should have your chemistry textbook. So you cannot be borrowing course subjects, the textbook for course subjects like chemistry, maths, and physics from students. It's not helpful at all. Then you also mentioned that we should, like in terms of you explained the practicality of solving, like memorizing equations. So you should list out the equations, the reactions rather, and then instead of trying to memorize what happened, it's best to just understand the equation, the reactions, and then list them out. And when you do that, you're now able to form a storyline from, okay, this happened first, and this happened next, and then you can now develop your story from there. So that was something I also picked out for WAEC. Then you mentioned for JAM that you need to have the JAM syllabus. You need to use the JAM syllabus to read. So if you're here, you're preparing for JAM, aside having the JAM past questions, you also need to have the JAM syllabus. And then you mentioned that for A level is more of applications than theory. So you really have to understand what happened or what's made a reaction happen, because the questions are more technical. So I hope that we put that into consideration and we apply that when we are studying. What just came to my mind as you're talking was how some students are doing, many students right now are doing A level
I can't hear
or
you clearly.
JAM
Yes,
at the same time. Can be a lot. So we really need to. Can you?
I can't.
Sorry about that.
I guess it's a network.
Yes. Can you hear me now?
Yes, yes.
Okay. So I was saying that many students are studying for one or two or more exams at the same time, and it can be a lot. So I believe if we're able to put some of these things into consideration when we are studying for these exams, it will be very helpful. So thank you very much, sir. I saw a question in the chat, so we can treat that question. So Toluwalashe asks that what are the career paths in chemistry and how do you identify your strengths?
Okay. The career paths in chemistry are many. Let me start from the academic point of view. One can be a teacher of chemistry. And when I say a teacher now, it goes beyond what is obtainable in our local school. You can be a teacher of chemistry and be an international person. There are quite a number of my colleagues who are in the UK who are teaching chemistry, and they have their UK qualifications, NQS, NQTS, I mean QTLS, sorry, QTLS. There's one certificate of notarization, a certificate of, I'm trying to remember now, I've forgotten. That certificate will be used to evaluate your degree from Nigeria and then be able to fit into the UK system. So one can teach abroad as well, and you'll be living fine as a teacher of chemistry. So you can also teach in Nigeria. Maybe one will do other business to support to be able to get good finance, you know. So teaching is one of them. A subsidiary to that is lecturing, which is also teaching though. So in Nigeria, one can also lecture in higher institutions, but at least one needs to have like a master's degree to start lecturing. Though in the northern part, I'm aware some people with just BSc are able to lecture. But of course, we know in southwest or southern part generally it's highly competitive. So if one is going into the teaching line, it's advisable to have at least masters so that one will start from a good level. That's for teaching. And then the other career is also in the industry. Yes, I also have some colleagues who who work in some industries, some factories, even in Ibadan there. There's this Nigerian bottling company at Ashejire along the Kiri Road from Ibadan. So one can work there as a chemist. Yeah, you can work there in the industry. You can also work in there's some pharmaceutical companies too. Pharmaceutical companies in Lagos, in Kwara State, some paint production industries. One can work there. So many industries need chemists. Yeah, yeah. Except if it is accounting, if it is accounting firm or social science, that's where one cannot fit in. But many industries need um, chemists. So one can be a teacher, a lecturer, one can work in industries, and then one can also be a consultant. Not so many people know this, but one can be a consultant. I know some professors in UI who are consulting with some multinational companies. Yeah, they are industrial chemists. Our host here is an industrial chemist. So some of these professors are industrial chemists and they are consulting with those companies, and of course they are well paid. I'm sure the money they are getting there is even far more than what they are getting as as lecturers. So these are the careers in chemistry. We also have other areas that are this silent. There's forensic chemistry. There's forensic chemistry and many others. Yeah, there's forensic chemistry. There's now in terms of the branches, we have physical chemistry, we have inorganic chemistry, we have industrial chemistry, we have analytical chemistry, environmental chemistry, we have forensic chemistry, we have petroleum chemistry. Yes, we have um, medicinal chemistry. Yeah, medicinal. We have pharmaceutical chemistry. All of these are areas that will make a chemist to fit into so many sectors in the labor market. Thank you. You are muted, the host.
Okay. So how do we identify our strengths and what areas to get into?
Okay. How we can identify our strengths is simple. Most times when I meet students who want to proceed to the higher institution, I always ask them for their best subject. And their best subject. Sometimes the best subject may not be their strength. It may be conflicting, but it's not. One's best subject may not be one's strength. My own best subject is mathematics, but I feel that I also enjoy chemistry. Yes. So how to identify one's career is knowing one's uh, strength. Like, okay, for instance, I know I like mathematics. I'm good at mathematics and I'm studying chemistry. Perhaps, perhaps I would have been miserable if I had gone for environmental chemistry because in environmental chemistry it involves a lot of cramming. They deal with soil, they study water, they study different environmental things. They study all these heavy metals in the soil, heavy metals in water, different things that have to do with the environment. They even take samples from oceans depending on the research field. So when I know that I'm not good with cramming, I know I'm good with mathematics, but I'm studying chemistry. So I can either go for physical chemistry or go for maybe analytical partially. Yeah. But most other aspects requires like more like cramming. So, but if you know you are good with memorizing things, then you can of course fit into environmental chemistry, industrial chemistry, and other aspects. Yeah.
Thank you very much, sir. So I don't know if anybody else has any other question. We'll be wrapping up. We'll be uh, rounding this up. So please, if you have questions, now is a good time to send them to the chat. Toluwalasha, I hope your question has been answered. You can let us know if your
Yes,
question.
thank you. Thank you very much, sir. Thank you, ma'am. My question has been answered.
Thank you. Okay, so I don't know if any other question will come in, but sir, I'd like you to, as we round this off, what what would you say to students, more like from, I know you've mentioned a lot already about this, like how you studied and got to the level that you are. So what students like, or what would you say to your younger self? What do you wish that maybe you did, but you could have done quite differently, you could have done better, or that you could have improved upon to us here in terms of chemistry and learning in general?
Okay. The advice I would have given my younger self, right? Okay. As a student of chemistry, the advice is try and avoid distraction. Yeah. This technological age, it's one of the biggest distractions. I still advise a master student in UI that he should avoid his phone. Now, this person is actually studying chemistry though, and I told him that because I noticed if, for instance, you want to read and you want to read like 5 pages document, since the material is hard copy, and at that point you are not picking anything from the internet or from your phone, the best thing, put your phone on silent. In fact, let the phone face down. Let it not even face up, that you know that, oh, it is there's a message that comes in. Put it on silent and let it turn the screen upside down, so you don't even know whether that message comes in or not. Take a decision that you won't touch it because it can be tempting. So when you do that, you want to read your material. I bet you within maybe 2 hours or 1 hour, you'll have read the 5 pages document and understood a lot of things there. But if while you are reading, you are pressing phone, you are checking somebody sending message to you, you drop the material, you try to reply a message. The truth is, one will be greatly distracted. Yeah. So, but when you are focused, you make sure that you don't get distracted when you are reading. You only press the phone when you feel bored and like you want to do other things. Then pick the phone, focus on the phone, press it for 30 minutes or 1 hour. If you want to read, focus on the reading squarely. Thank you.
Okay. Thank you very much, sir. There's a comment here talking about that there are different approaches to solving calculations in chemistry, especially relating to mole. So you can, I think you can, don't just get stuck on a, maybe you're not getting something, try other ways, check for other solutions. So you might employ the use of videos or textbooks. Now different textbooks, I'm sure it can help you. So it is cool to read chemistry when it doesn't involve calculation. Okay, so I don't think there are, thank you very much for this comment. um, I appreciate it. So I think, please, as students, let's not get discouraged. I struggled with chemistry while I was in secondary school. And as Dr. Akintemi said, for me, I believe it was the teacher, because I didn't have issue with it in SS1. In fact, I enjoyed it, or I liked it, or I saw that it was, aside maths, I enjoyed doing chemistry. So in SS1, it wasn't an issue for me. When we got to SS2, I found out that this teacher, like he said, I think he just found himself teaching this chemistry. He'll be telling us stories of how he wanted to go into medicine, but it didn't work out for him, and then it just ended up here, and it was very depressing. It was very depressing. So he wasn't teaching this thing very well, and then I started struggling. So, but at the end of the day, it depends on you as a student to overcome these challenges. You can't blame another person or teachers for our own successes or failures. So there are certain things that you have to do: get your chemistry textbook, get past questions, employ the use of other aids, ask people questions, meet people, watch videos, and I believe these things would really help you. So, sir, as we round off, is there anything else that you'd like to say? Okay, so that you raise your hands. Is there anything else that you'd like to say and tell us as we round off this session?
Yeah, something came to my mind now. I would like to mention, just like I said earlier, that I passed through public school all through. So, even despite the fact that I had very good teacher, my SS2 and SS3, as a teacher of chemistry, though. So, I still noticed that some topics were not covered. Some of those topics in Ababio were not covered. So, when I was reading for my second YX, what I did was to identify those topics that were not taught at all, like they were not touched throughout. What I did was to identify those topics. I sat down and I was reading them. I had to just pick those because I noticed some of those topics, questions appear on them. So we have questions on them in YX, but I wasn't taught from SS1 to 3. So I took it upon myself to pick those topics, read them to the best of my knowledge. And then if one is fortunate to have someone around who can put you through those topics, because in my own case, I didn't have someone to like put me through some of those topics that I read myself. Yeah. But I had to, you know, set my mind to read and then try to get questions either from jam pass questions or Y pass Y series to be able to get good some points out of those topics. So and with that, there are some of those information that I still know up and to date. Yeah. So that's my advice to uh, the participants.
Thank you very much, sir. I really appreciate you honoring our invitation. Thank you very much. We do not take this for granted. Um, so I'll be ending this session now. I don't know if there's anything else that any participants here would like to say, or if you'd like to ask anybody before we end this session. Thank you all for joining. Thank you. A big thank you to those that stayed from the beginning to the end. Toluwa Lashe joined quite early, very early, in fact. Thank you very much for that and for staying true. I see Olatunji Victor on the call, Oguntola, Damilare, Babatunde. Thank you very much for staying till the end of this session. We really appreciate you. So, wrapping this off, I would say this is our first subject series. So still be holding other sessions. And if you'd like to be part of those sessions, like looking at other subjects like mathematics, the arts, biology, and even and unconventional subjects like writing and things like that, So if you'd like to be part of them, you can join our group or just follow us on our social media pages to get information and updates on these things. Thank you very much, sir. Once again, we really appreciate you, and we hope that you have a lovely night. Thank you, sir.
Thank you, everyone. Do have a wonderful night's rest and a great week ahead. Bye.
Bye, everyone.